Hello! In this video, we'll be covering regression algorithms. Regression originated from statistical modeling, and since machine learning is a much newer concept, it has adopted regression analysis. Regression outputs a response that is ordered and continuous. The output consists of one or more continuous variables. There are many different types of regression. The most common is linear regression. This will be the type of regression that you'll be implementing in a future lab exercise. There's also parabolic regression, which can go on and on to infinite degrees. In essence, we can call all of this polynomial regression. With many types of regression to choose from, there's a good chance that one will fit your dataset well. It's important to pick a regression that fits the data the best. Regression is able to create and use a trend line that can fit the data points that are present. Following the trend line is what's used to create a prediction. A good example of this is stock market trends that can be predicted using machine learning algorithms. Remember, however, that it's still a prediction based on previous data. Let's talk a bit about why linear regression is so useful. Quite simply, it's the most basic regression to use and understand. In fact, one reason why linear regression is so useful is that it's fast. It also doesn't require tuning of parameters, so something like tuning the k parameter in k nearest neighbors isn't something to worry about. Linear regression is also easy to understand and highly interpretable. Linear regression does have its drawbacks, though. For instance, it has a high variability on predictive accuracy, depending on the trend in the data. If the data shows a parabolic trend, then linear regression will not produce very accurate results when compared to parabolic regression, because, as the name implies, linear regression presumes that the data is linear. Regression can be used to predict future trends based on previous data. If you recall, the main form of regression that's been discussed was linear regression. Linear regression assumes a linear relationship between the input, or the x-axis values, and the output, or the y-axis values. Regression is part of machine learning because the machine is able to learn about trends and fit the data to produce the most accurate model based on previous data. All of this can be done without being explicitly programmed. Regression falls under the supervised learning section and produces continuous outputs rather than discrete outputs like KNN might produce. Regression isn't always linear. In fact, many different regressions exist that can be used to fit whatever the dataset looks like. You can see quadratic and cubic regression lines here. Don't forget about the evaluation metrics that can be applied to a model to evaluate how well it does. There's mean average error, mean squared error, and root mean squared error. The least popular metric is mean average error, and the most popular is root mean squared error. There are other regression techniques out there, such as support vector machine, ordinary least squares regression, and logistic regression. Please feel free to spend some time researching these if you're interested in learning more. Thanks for watching.